Hello and welcome to Empowered Learning. This video will be about the subsets of the real number set and how to be able to determine what those numbers are. So we start off here with the basic subsets of the real number set, and we start off with the natural numbers. The natural numbers are also called counting numbers. They're just numbers that you start to count off with: 1, 2, 3, 4, 5, 6. The whole numbers are all the natural numbers, but you just add 0 to that particular set. So you say 0, 1, 2, 3, 4, 5, 6, so on and so forth. Integers are positive and negative whole numbers. So if you notice, you see here that the integers has everything within the whole number. So we see 0, 1, 2, 3, 4. We also see that here, but we also have the negative numbers as well. So our integers are just positive and negative whole numbers. And if you notice, every natural number is a whole number. Every whole number is an integer. So these sets sort of feed into each other. Rational numbers are essentially numbers that can be written as a fraction. And so the way that it's shown here on this slide is that it says the set of all numbers that can be expressed as a quotient of integers with a denominator not equaling 0. So as long as we can write some number divided by another number where our numerator and our denominator here can be an integer, but we do not want our denominator to equal 0. Okay. Now that's one definition for it. Another way to interpret a rational number is to say, is to look at it in terms of a decimal number. Rational numbers are numbers that can be written as a terminating or repeating decimal. And so we'll start off here. That didn't turn out too well, so let's see if we can redo that. So here for rational numbers, we want terminating or repeating decimals. Having some issues with this pen here. All right, so to give you an example of a terminating decimal, that would be like the number 2.75. And so we call it terminating because we could terminate the number with 1 0, or we could do it with a bunch of zeros, and it doesn't change the quantity of that number. So that is an example of a terminating decimal. A repeating decimal is a number like 1/3. If we take 1/3 and we put it into a calculator or just divide it out, we'll see that we'll get 0.3 repeating, 333333333, like that. So those are examples of numbers that are either terminating or repeating. If we have numbers that cannot be written in decimal form as a terminating or repeating decimal number, then that is what's called an irrational number. And so examples of irrational numbers would be famous numbers that we have symbols for, but we actually don't have a number quantity for. So for instance, I'm pretty sure most people have heard of pi. And we know that pi is approximately equal to 3.14. It is not exactly equal to 3.14. It's approximately equal to that. And pi represents the ratio of the circumference of a circle, which is basically the distance around a circle, with its diameter, the distance across it. Okay. Of course, this is approximately equal to 3.14. We also have another number called e, which is called the Euler number. It is approximately equal to 2.71. But again, this is another number that is, we do not have a quantifiable way of expressing it. Okay. The other important way to come up with irrational numbers is to take the square root of any prime number. And of course, any prime number, a number that is only divisible by itself in 1. So for instance, square root of 3, square root of 5, square root of 7, square root of 11, all those type numbers are what we call irrational, meaning that we cannot write those in fraction form. And so if we look here, we see that the real numbers is just going to really end up being all rational numbers plus irrational numbers. And that equals what we call the real numbers. So what we want to do in this next exercise is look at a list of numbers and then figure out where they belong. So let's go ahead and look at that now. All right, and so before we actually get into that particular assignment, we want to make sure that we understand what the basic number line looks like. And we know that all positive numbers are numbers to the right of 0. And we know that all numbers that are negative are ones that are to the left of 0. So positive numbers over here, negative numbers over here, and of course 0 is a number that is neither positive nor negative. So now looking at this list of numbers here, we're going to figure out which ones are natural numbers, whole numbers, integers, rational numbers, irrational, and real. So let's take each number and figure out everywhere where it belongs. So we know that natural numbers are numbers like 1, 2, 3, 4, 5, 6. And whole numbers are numbers like 0, 1, 2, 3, 4, 5, 6. So here we know that if we look at our first number here, which is a negative 1 1/4, and by the way, a negative 1 1/4 could be rewritten as a negative 5/4. And of course, the reason for that is whenever we convert a mixed number into a fraction, we just say 4 times 1. We're ignoring the negative here for now. So we're going to say 4 times 1 and then add 1 to it. And so when we rewrite that, it looks like this. And of course, if we wanted to go back the other way, we would take 4 divided into 5, and we know 4 goes into 5 one time. Subtract 4, and we would have a remainder of 1. And so that's how we come up with the 1 1/4. And of course, that would be negative. So anyway, so we look here and we see that negative 1 1/4 can basically be written as a fraction. Okay, so since it is a fraction, it can only go here within the rational numbers. Okay, we can't call it an integer because negative 1 1/4 is not a negative whole number. So in decimal form, negative 1 1/4 would actually be a negative 1.25. So that's why negative 1 1/4 would not be an integer. Now, it wouldn't be irrational because, of course, negative 1 1/4 actually can be written as a fraction, okay? But will be a part of the real numbers because all these numbers here are going to be a part of the real numbers, okay? As a matter of fact, I think I'll just delete that and just say all of them here to make that simple. Okay, let's look at the second number, which is 2.5. Okay, 2.5, it is a decimal number, and it's a decimal number that is written in terminating form because, of course, we could put 0 on the end here and it doesn't change it. So we know that it is indeed a rational number. Okay. We can't call it an integer again because it's not a whole number. So we just have to leave it at that. So for the next one, 3 over 2, or 3 halves, we know that this is a number that can be written as a fraction. So again, this would be a rational number as well, and a real number. Negative 3.75, this is a terminating decimal number, so we would definitely call it a rational number, and of course it'll be a real number. For 15, 15 is a counting number. If we start off 1, 2, 3, 4, 5, 6, so on and so forth, we see that 15 is one of those numbers, so it can be considered a natural number. And since we know every natural number is a whole number, it can also be considered a whole number. And every whole number is also an integer. So of course it can be considered an integer. Now, the question is, can it be considered a rational number? And the answer to that is yes. The reason why is because 15 is the same as 15 divided by 1. So 15 can be written as a fraction. So here we would have to consider that to be a rational number as well. 15 is not irrational because, of course, it can be written as a fraction. So we wouldn't consider that. And of course, since it fits at least in one of these sets, then it's a real number. So the next number that we look at is square root of 2. So since 2 is a prime number, then we know that taking the square root of a prime number is going to be irrational from what we talked about before. So we would put that here. And we know that square root of 2 is one of those numbers, again, that you can't write out as a fraction. So that's why it wouldn't be a rational number or an integer or a whole number or a natural number. Okay? So we've taken care of all of these. Now for the number 0, we know that 0 is not a part of the natural numbers because we know that for natural numbers, we have to start with the number 1 and go up like 1, 2, 3, 4, 5. But it is a part of the whole numbers because we know whole numbers is just all the natural numbers with 0 added. So here we would consider 0 to be there. It would also be an integer, and it would also be a rational number because, again, 0 can be written as 0 divided by 1. And of course, it wouldn't be irrational because it can be written as a fraction. And if it's a part of one of these sets, then it's a real number. And then the last one is negative 5. We know that negative 5, since it's a signed number, it would have to, at the lowest terms, be an integer. And we can also write it as a rational number. But it wouldn't be irrational because, of course, negative 5 is the same as negative 5 divided by 1. And so this is how we can look at a set of numbers and tell what subsets within the real number set it fits in.